Hi, today we're going to be solving absolute value inequalities. So far, we have worked with inequalities. An inequality is a mathematical sentence that compares two values using the greater than or equal to, less than or equal to. We've already worked with those. And we've already worked with compound inequalities, which are two inequalities joined by an and or an or. What we're going to be working with now are absolute value inequalities, which means there's just going to be an absolute value expression in that inequality. Okay, for the first absolute value inequality that we want to solve, we're going to follow the 5 steps that are up here. We're going to follow these 5 steps in all absolute value inequalities. Now, step 1 is to get the absolute value symbol alone. This absolute value of w plus 2 in the example is all by itself. That means there's not any numbers out in front of the absolute value or behind the absolute value. Step 2, we want to rewrite the two inequalities. And we're going to have to remember to flip and switch in the second one. Step 3, solve each inequality. Step 4, graph your solution. And step 5, write the solution as a compound inequality. Write your answer of that. So let's take a look at example 1. When I read this as the absolute value of w plus 2 is greater than 5. But when you read that greater than symbol, I want you to mispronounce it as a greater than. If you mispronounce it as greater than, you know what word you need to put between your two inequalities when you translate it. So my first inequality, when I go to translate, it's going to look exactly the same as what's in the absolute value up above, but there are no absolute value bars. So w plus 2 is greater than 5, or, because it was a greater right here, and then I start writing w plus 2, but then I have to flip the inequality and flip the sign on the negative 5. Now when I do that, I have a compound inequality that I need to solve, so I'm going to subtract 2 from both sides. I have w is greater than 3. I'm going to bring my or down. I'm going to solve the other one on the right-hand side, and I'm going to have w is less than negative 7. That is my solution, and then now I want to graph that. When I graph it, just like when we did our compound inequalities, make myself a number line here. I'm going to call that negative 7, negative 5, negative 3, negative 1, 1, and 3. So w is greater than 3 would mean that I want an open circle on 3, and then I'm going to shade to the right. Remember, an OR scenario can do whatever it wants, but usually they go in opposite directions. And w is less than negative 7, so open circle on negative 7, and shade to the left. Let's take a look at the next one that we have. Okay, this is the absolute value of 2x minus 3 is less than or equal to 4. So this is a less than or equal to. So I want you to mispronounce that less than or equal to as less than or equal to. So I want you to mispronounce it as less than or equal to. So when you say less than, you know this is an and situation. So when you go to translate it, you can write it as 2x minus 3 less than or equal to 4. And remember that first inequality on the left should look identical to what's up in number 2, except no absolute value bars. The second inequality I write is going to be 2x minus 3 greater than or equal to negative 4, because I have to do a flip and a flip on the last two pieces, as step 2 up above says. Now I can go through and solve this. So I would add 3 to both sides in that left inequality. 2x is less than or equal to 7. Divide both sides by 2. X is less than or equal to 7 halves. Or I could say that that's 3.5. I have an and. I could solve the one on the right by adding 3 to both sides. 2x is greater than or equal to negative 1. Divide both sides by 2. X is greater than or equal to the negative 0.5. Now I can use this solution, and I can graph that solution. And quickly graph that. So if I make this negative 1, 0, 1, 2, 3, 4, 5. X is less than or equal to 3.5. means that I go to 3.5 and I have a closed circle at 3.5. And then I go to the negative, and I would shade less than, so that would be to the left. But the other inequality says x is greater than or equal to negative 0.5, so I'm at negative 0.5, and now the one's greater than. And so this particular situation is between those two values. The solutions that work for this absolute value inequality are the ones in the shaded region. And I want to show you one other thing. When you go to solve this, absolute value of 2x minus 3 is less than or equal to 4, you can also solve an AND situation by taking the 2x minus 3 less than or equal to 4 and putting the less than or equal to on the left-hand side and then changing the sign on the 4 and putting the negative 4 there. You can solve it either way, either the way I did in the purple or the way I'm doing it in the red. Now when you go to solve it the way I have it in the red, we get this negative 1 less than or equal to 2x, less than or equal to 7. Divide both sides by 2. I am going to get the exact same answer. It's just written a little differently than my first example. But it means the same thing. It's saying that x has to be between 3.5, negative 0.5, and include those points. So you can solve it either way by using the and doing the two separate inequalities, or you can write it as one big compound inequality. Let's try another one. Okay, let's take a look at this one. This looks a little different than the others just because our absolute value is on the right-hand side. What I'd like to do before I do anything is I'd like to make sure the absolute value is on the left-hand side. So I'm going to rewrite this with the absolute value on the left-hand side. So I'm going to have absolute value of 6y minus 2 less than 22. So when I flipped it around, you notice how it was pointing to the absolute value? It's still pointing to the absolute value. So it means the same, it just looks differently. Because when the absolute value is on the left-hand side, this is when I can read the inequality as the greater than or the less than. So this is absolute value of 6y minus 2 is less than 22. So this scenario is a less than. Remember how I said mispronounce it? So you know it's an and situation. So what I want to do to solve this, I'm going to do 6y minus 2 less than 22, because my first inequality has to look exactly like what I have up there, except no absolute value bars. And I'm going to solve this the way I did the part 2 in number 2. I'm going to put the less than there, then I'm going to take that 22 and I'll put the negative 22 here. I'm going to solve as a compound inequality like this. So I'm going to add 2 to all three sides. I get negative 20 is less than 6y, which is less than 24. And then I'm going to divide all the sides by 6. And that's going to give me the y in the middle. And 24 divided by 6 is 4. Negative 20 divided by 6 here would be what? Negative 3. So it's what? 18, 2, 6, negative 3 1/3. And then I would want to graph that. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So I do my number line here. And it says that y is between 4, so an open circle on 4, and open circle on negative 3 1/3. So that's just part way right here. And then I need to shade in the middle. So this example here says if the absolute value is not on the left-hand side, you need to put it on the left-hand side first before you go about solving it. Okay, we have one more example. Okay, here's my last example, number 3. Alright, well, step 1 always says to get the bars and stuff inside on their own side all alone. Well, first of all, I really don't like how the absolute value is on the right-hand side, so I'm going to rewrite this first. So it's negative 3 times the absolute value of 2x minus 1. And it's pointing to the absolute values. Keep it pointing there is negative 9. So I wanted to rewrite it so my absolute value is on the left-hand side. And then when I notice I've got this negative 3 out front that I don't want, haven't had one of those, so what I'm going to do is I'm going to divide both sides by negative 3. And when I do that, I get the absolute value of 2x minus 1. Remember, you got to flip this switch because you're dividing by a negative, and I get 3. Now let's just take a look at this for a moment. This says the absolute value is greater than or equal to 3. Well, when is an absolute value greater than or equal to a positive number? Anything that comes out of absolute value bars is always positive. So this positive number that you're going to get out of this absolute value bar, when is it going to be greater than or equal to a positive 3? Well, all positive numbers are greater than or equal to 3, so this would be in all real numbers. You can also go through, if you went through and tried to solve this as an OR situation, when you go to graph it, you'll notice that the entire number line gets graphed. That's why it's an all real solution. I just want to point out that if you did solve something like this, and suppose that you get the absolute value of 2x minus 1 is less than or equal to, suppose we got negative 2 there. Well, when is a positive number, because anything that comes out of absolute values has to be positive, ever less than or equal to a negative 2, a negative number? Never. So if you ever get into that situation, you would write no solution. Okay, that's it for the absolute value inequalities, and we'll do some more in class next time.